Hello class. In this video we're going to take a look at the differences between println, printline, and printf, the formatted print. So we've been using print and printline the entire time, and to use that we would just put into it the string of text and we would concatenate any variables we wanted to print, and it would be a pretty static layout depending on the size of the text and the variables that we wanted printing. Well, printf gives us a lot more flexibility and allows us to control how the output is displayed. We can format strings, integers, floating point numbers, and we can affect their alignment, whether they're left or right justified. We can combine multiple variables into one output formatted string, and we can apply some real-world formatting, such as dollar signs, and make reports in columns. So we're going to go through a couple of examples, and this should cover section 13.1 of our textbook. So I've also gone ahead and opened in another tab our testing environment, so we have that available to us. And why don't we start with just a simple example. And I will start with a simple variable, single variable, int age equals 21. And what we have done in the past is to print out the person's age, your age is, and then we would do something like this, and we would add the age in there, and that worked. And I'll run it just to prove that works. And there it is. Well, we can do the same example with system.out.printf, the formatted print, and it's a little bit different. So we have one string, your age is, and this is where it gets different. This is where we use the placeholders. We're going to use a placeholder for what we want to have displayed here. So in this case, we want to have the person's age displayed. So age is an integer, and we want it to be displayed as an integer. So we're going to put in here a %d. And I'll go over what all these percent items mean in a minute. And then we list the parameters, kind of like a method. We're going to list the parameters into printf, and we're going to put in here age. And when I run this, we get the same exact output, with the slight exception of this does not automatically print a new line character, which is what we would normally want to have happen. So we can put in a %n to do that, and now it prints it on its own separate line. So you could see it's a little bit easier. We have one string, and we have one parameter that goes into that string that fills in the placeholder where the %d is. So if we look in our textbook, here is a list of format specifiers or placeholders into the format string. So you see we have %c is for a single character. %d says decimal integer. Now you may be thinking like a floating point number, right? Like a 5.3 or 2.1 or something like that. No, it's not that. It's an integer. It's integer such as a person's age, 19 or 21 or 43 or whatever, what have you. And then it converts it to a decimal base 10 output, which is what we normally use. Everything we count in groups of 10. We also have %o for an octal integer, which is base 8, and h, %h is for hexadecimal, which is base 16. Probably not often used, but just know that they're out there in case you need to. And then you have your %f for your floating point. So now you can do your decimal points. And you can put other modifiers on here too to display a certain number of digits. And we'll take a look at number of that in a minute after the decimal point. And then you have %e for your floating point in scientific notation format. And we have %s for string. Now if you wanted to print the actual % character, you have to tell it that you want to do %, because % is the indicator that something special is going to happen. That's the escape character. That's the character that when it's being processed, it says something special is going to happen to the next character. So if I say %, that's an indicator that, oh, I really just wanted the % character. And here's that %n for the new line character, which we showed before. So back to our example. I'm going to comment out the original one, because we're not going to use that anymore. And we're going to just use printf from now on. So if we take a look at this, we see we have one parameter, age, that is put into our printing string. %n is the carriage return for the new line. So what if we wanted to put a person's name in here? Well, why don't we put a person's name in there? Person's name is Alice, and now we have a name. So we have a string. We want to add the string to it. We can make a new format string that looks like this. %s, right, for strings. Come back over here. %s for strings. And we could do your age is, and we could do the %d, %n, same as we had before. Now we have to add in two parameters. We have to add in the name and the age. Now the trick here is that you have to list the parameters, the name and the age, that match the order they appear in this format string. So the %s has to come first, and then the %d for the age second. Alice, your age is 21. If I did reverse it and put age before and I ran it, it just gets really mad and throws a big error. So it tells us that we have an exception and the formatter broke, the formatting string function broke. So that's an indication we have the bad parameter list. So let's fix that. And there we go. We can give Alice a GPA. Alice is pretty smart. We'll give her a 3.78. And now we can print her GPA. So for this, we'll keep the %s. Your GPA is, and now we want to do something a little different. We want to print out her GPA, but now we need a different modifier because we're using a double. So if we're going to use a double, it says we have to use %f for floating point. So %f, and we can do %n again, just so we have the new line. And now we need name and GPA. And if I run this, I have 3.780000. That doesn't look that great. So what we can do is we can limit the number of decimal places that we want to have after the %f. And I'm going to move this %n out just a little bit so we can type in. We're going to type in here a little bit. So the %f has the ability to take a modifier. And we can modify the %f to indicate how many spaces after the decimal point we want. And we can do it like this, 0.2f. Put the 0.2 in there, and that tells us after the decimal point we want 2 places. 3.78. See, we got rid of that extra 0000 that we didn't want to see. Now, if we go back to our textbook, and we scroll down just a little bit, you see you have some modifiers here where you could give it the width, the width, the precision, and it says dot precision, so you get an idea of the decimal places, and flags. So the width specifies the minimum number of characters to print. So it's kind of like how big a space do you want to put this in. So the %7.2f, well, the 0.2f we know is the precision, and the precision is 2 decimal points. The %7 is 7 characters wide. So let's take a look. %7.2f, and it looks a little weird, but once you get a handle on what all these different modifiers mean, you can really get fancy with it. So you see the 0.7 said print this in 7 places. I'm going to try to highlight it and so you can see and count it. So the 3.78 is 4 characters. And then if you look under the 2 and under the 1, and under the space, there's 3 more characters here. So this is 7 characters wide that it put it. And I can change it to, let's put 17 and make it ridiculously big. And you can see it'll be shifted all the way to the right. So you can really line up now columns, rows of data based on specific formats and lengths of columns. And we'll see that when it comes to reading tab-separated values and comma-separated values that you're going to see in some of your labs. For now, let's leave it at 0.7, at 7 wide, with 2 decimal places. And there's some other modifiers. You can force it to print a plus for positive numbers. Negative numbers always get printed with a negative sign, so you don't have to tell it that. But if you wanted the plus, you could force a plus in there. If you wanted to pad it with zeros, you could put that in as well. So let's try that. Let's put the 0 in front of it. Just 0, 7, 2F. As you'll see, we should see 3 zeros filling the spot here. And there it is. And we can, we'll hopefully do the whole 9 yards. We'll put the plus in there as well, and we'll get that in there. But you see, it's still 7 characters. So whatever you're telling it in the width of the field is what you're going to get. Now we noticed that if we had, let's take the 0 and the plus out for now. Let's just go back to plus 7, 7.2. So 7 positions, 1, 2, 3, 4, 5, 6, 7. And 2 of them are decimal places, so we have 7.2. What if we wanted to have this shifted to the left? Well, we could, instead of using the plus to display the plus sign, we're going to use a minus. And the minus says left align it. So in this 7 positions, 7 characters that we reserve for this field, we're going to start printing from the left this time instead. We'll see what that looks like. Now it's hard to see, but there are more positions over here. So let's put in just the word there to see. So you can see how the word end is shifted all the way to the right. It's put all the way after the 3.78. It fills up those 7 positions. So you can left and right align columns, so you can really line up your output and make it look organized. So we've looked at ints, we've looked at floats, and you can see that in their textbook there's some great references. These charts are really pretty good in the textbook for this, to give you the list of formatters, the list of modifiers, the width, the precision, and any flags. We have a similar one for integers. We have width and flags. No precision for integers because, well, there's no decimal places. And then we also have our string formatters. And let's take a look at some of those. So we'll go back into our testing environment, and we'll create a new string, and we'll call it test string equals the quick brown fox jumps over the lazy sleeping dog. And we can do some modifiers for that as well. System.out, system.out.printf. Our string is %s. And we'll list in test string. I'll do a quick run to make sure that works before we go any further. And it does not. And I forgot to do print F, that's why. We'll run it again, there we go. Oh, and I forgot the %n to make it go into a new one. We'll leave that for now. So this prints out the entire string in this big field. So let's look at our modifiers. We have the width modifier, which will specify the minimum number of characters to print. If the string has more characters than width, the value will not be truncated. If the formatted value has fewer characters, the output will be padded. So it prints the full thing, and if it needs more room, it'll put in spaces. So let's take a look at that. Maybe I should have used a smaller string here. %s, let's do 100. We'll do a really big number to see what it looks like, because it's a big string. So here's the extra spaces to get to the 100, right? And if I did a smaller value, 10, it's not going to truncate it. It's going to give me the full string. And there it does. So you can see you can do the same thing with column width or field width with integers and strings and floats, all the same. Now you can also tell what the maximum number of characters is. So your width is the minimum, and now the precision is the maximum. So if I did 10 dot, or not 10, sorry, and I run it, I get the first 10 characters. So I can truncate it if I wanted to, for whatever reason. And then I have my flags for the minus for the left align, and that works the same way as it did for integers and floats. Okay, so that's a quick scenario, a synopsis of what is the formatted printing and how you can use that to make more fancier, more detailed, more professional looking output. Keep these charts handy. They give you some great references, so that's good to have. The other thing you'll want to keep an eye out is for some common errors. So what kind of errors could you make in here that could cause you a little grief? Well, the first thing you want to think about is the %d. Remember, %d is for integers, not doubles, right? Integers, and it prints it as a decimal formatted integer, meaning base 10 math, not a d for a double, which is the fractional numbers. That's where we use a %f for that. Forgetting the new line characters. If you forget the %n, all your output is going to just be put on one line, and it's just going to keep putting on one line after, scrolling all the way to the right. It might be hard to read that way. Another common error is you may leave off a required modifier. And it'll tell you, Alice, your age is, exception, format specifier %d, missing format argument exception. Oh, I'm missing an argument. Not a very clean error, but it gets the point across. So you make sure you have the number of variables that match the number of your % modifiers. And the last, well, it goes without saying, make sure your string is surrounded in double quotes. It is a string, and it needs to be surrounded in double quotes. Okay, so that's it for now. I will post this code into our test section, but try it. Give it a try. Put some different values in there. Play with the different modifiers, and see what you can come up with. That's it for now. See you in the next one.